Hey guys, it's Jamie here. So today we had Aircraft Systems and Performance 2. And we just went over a couple of things. We went over the atmosphere, not literally, but parts of the atmosphere. We went over the rules governing the International Standard Atmosphere. And we went over a couple of equations which are used for the troposphere. So in terms of the atmosphere can be treated as a homogeneous gas which surrounds the Earth and can be regarded as being stationary. We can split the atmosphere into two regions: the troposphere, which I will just draw on a little graph. So up to around 11,000 meters, will be our troposphere, misspelled sphere. This is going well. And then above that we have the stratosphere. Now, in between the stratosphere and the troposphere, there will be a little region called the tropopause, which is the point at which there is a transition from the troposphere to the stratosphere. Now, in terms of temperature, in the troposphere, the temperature varies linearly with height. So, as the height increases, the temperature decreases. But then as we reach the stratosphere, the temperature reaches a point and then it stays constant, no matter what height you are at. Next, we have the International Standard Atmosphere. It sets standard atmospheric conditions which can vary with Arctic conditions and tropical conditions, a general set of rules which allow us to make calculations all over the world. Okay, so finally we have the troposphere. We're going to go through a couple of basic equations which we went through today. We went through them all during fluid mechanics and thermodynamics, but they allow us, it shows us that what we were doing last year wasn't just a load of nonsense. It is actually useful. So finally we have the calculations in the troposphere. We have a few equations which we can work with. We have the variation of pressure with height, dP, which is equal to negative rho g dz. We have the equation of state, P is equal to rho RT. And we have variation of temperature with height, which is T is equal to T naught minus LZ. L is the lapse rate, which is equal to negative dt by dz. So dP is change in pressure, rho is density, g is gravity, z is change in height, p is pressure, density, universal gas constant is R, temperature is T, T naught is our reference temperature, which is normally sea level temperature, but that can be anything between 0 and 11,000 meters, so anywhere in the troposphere. Okay, so first we can use these two equations, rearrange them to get them in terms of rho. So dP over dz multiplied by 1 over g. And this one rearranges to P over RT. We can then equate the two together. So we have P over RT is equal to negative dP over dz multiplied by 1 over g. Now, we mentioned earlier about the lapse rate. Lapse rate we can rearrange, so it's dz is equal to negative dt over L. We can then put this back into our equation, move P over, move the negative onto the other side. So we get dP over P equals G over RL multiplied by dt over t. We can then integrate, and then we get ln P2 over P1, which is equal to G over RL ln T2 over T1, which we can then write as P2 over P1 equals T2 over T1 all to the power of G over RL. Now this looks pretty similar to something that we've done in thermodynamics. Now we know that PV to the power of n is equal to constant. And from this, we also learnt a while ago that P2 over P1 equals T2 over T1 all to the power of n over n minus 1. So, since those two are pretty much the same, we can compare the coefficients. So G over RL is equal to n over n minus 1. And then using our standard values where G is 9.81, R is 287.3, and L is 0.0065, N actually comes out as 1.235. And this is great because it means that if we know the starting pressure and the starting temperature, we can find out the other two. We can find out the new temperature and pressure, which makes life so much easier for aeronautical engineers. So guys, that's all we have for you today. If you have any questions or any queries, please leave a comment in the description below, and don't forget to like and subscribe. Bye!